Most people hear fine-tuning and imagine engineers opening an AI model, tightening a few digital screws, and suddenly turning it into a genius lawyer, doctor, or customer service expert. Not exactly. Fine-tuning means taking an AI model that has already been trained and training it a little more on carefully selected examples so it performs better for a particular task, style, or behavior. But here's the real question. If a large AI model already knows so much, why would we need to train it again? Think of a general AI model like a highly educated graduate. It understands many subjects, can write in different styles, and can answer a wide range of questions. But being generally knowledgeable does not automatically make someone perfect for a specific job. A graduate may still need specialist training before working as a legal assistant, medical researcher, banking support agent, or technical writer. Fine-tuning gives the model that additional specialization. During fine-tuning, developers provide the model with examples of the inputs it may receive and the kinds of outputs they want it to produce. For example, a business may show the AI hundreds or thousands of customer questions alongside approved responses. The model then adjusts some of its internal parameters so that future answers better match the company's tone, format, terminology, and expected behavior. Imagine a restaurant using an AI assistant. A general model might answer a customer in a formal way, "Your request has been received and will be processed shortly." But the restaurant may want responses that are short, friendly, and consistent with its brand. Fine-tuning could teach the model to reply more naturally. "No problem, we've sent your request to the team." The model is not learning every company fact. It is learning how the company wants it to respond. This is also why fine-tuning is different from prompting. A prompt gives the AI instructions for one request or conversation. Fine-tuning changes the model's behavior more permanently across many similar requests. Prompting is like telling an employee, "Use a friendly tone in this email." Fine-tuning is like training that employee for weeks until the friendly tone becomes part of how they normally communicate. Fine-tuning is also different from RAG. RAG gives the model access to external information, such as updated policies, private documents, or product records. Fine-tuning changes how the model responds or performs. If a company wants the AI to know today's prices, RAG is usually more suitable. If it wants the AI to always follow a particular response style or classify support tickets correctly, fine-tuning may be more useful. A small case study is customer support classification. A company may receive thousands of messages about refunds, technical problems, billing, delivery, and complaints. A general model can try to categorize them, but a fine-tuned model can learn the company's exact categories and examples. This helps route each message to the correct department faster and more consistently. But fine-tuning is not automatically the best solution. It requires good training examples, technical work, testing, and maintenance. If the examples are biased, incorrect, or inconsistent, the model can learn those problems. It can also become too specialized and perform worse outside the narrow task. Training AI on bad examples is basically giving a talented employee a terrible manager and then being surprised by the results. Historically, fine-tuning became important because training a powerful model from zero requires enormous amounts of data, computing power, money, and time. Instead of rebuilding the entire model, developers can start with an existing model and adapt it for a particular purpose. This makes specialized AI more practical for businesses, researchers, and developers. So in one simple line, fine-tuning is the process of taking a pre-trained AI model and training it further on selected examples, so it becomes better at a specific task, style, or behavior. RAG gives AI new information. Prompting gives it immediate instructions. Fine-tuning changes how it usually performs. Welcome back to the AI Studio, where we make artificial intelligence simple, visual, and slightly less painful. But if different companies are building and training these powerful models, how do OpenAI, Google, Meta, and Anthropic actually differ? And are they competing to build the same kind of AI or completely different futures?